Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. The beginning week of every month we try to do a session for absolute beginners. So this is going to be that session. This assumes you've never seen Python before. We'll take you right from the basics. We'll be doing this with using Google Colab, which means you don't even need to have Python installed on your computer. There was another our meetup for next week, which was to use AWS Bedrock. We've had some problems getting the date right on that, so I think at the moment it might even say it's on exactly the same time as this one, but that should be October the 11th. So if you're interested in that one, be sure to sign up. All right, so on the meetup page and also below this YouTube video, I've got links that will take you to Google Colab, and that link will be a notebook that I've set up. So I'll have all the content for tonight, and you can just follow along. But it'll also have gaps in it that you can fill in bits if you want, and try things for yourself. So if you click on that link, it'll take you off to Google Colab and the notebook that I have shared with you, but you won't be able to save any changes that you make. So what I recommend is that you click on this copy to drive and make a copy for yourself, and that'll be just saved in your own Google Drive, and that way you can make as many changes as you like, and you can always go back to the original link if you need to pick up something that you might have accidentally deleted. Now I'm going to share this new notebook that I've made called Copy of Meetup 191, and so you can load that if I've managed to type something in tonight's session that you really want to keep and it's not in the original notebook, so you can grab it from that. So I'll copy that link and I'll paste it into Slack. Let's see if I can get Slack onto the right window. And let's just drag this title bar. There we go. Drag it quickly so it comes across. And in the Learning to Code session, hi Scott, we'll paste this link, and I'll also be doing that in the YouTube chat. Sign into chat. No, that's not going to work. Let's try this one. So you can contact me during the session on any of those, on either YouTube chat or in Slack. Slack is going to be a bit more reliable. YouTube tends to censor stuff on me, so I don't see everything that comes through. And if you need to join our Slack channel, then there's instructions in the YouTube video comments and also in the meetup comments to say send an email to skypieproject@gmail.com, and that'll organize it for you. Anyone with the link is a viewer. Good. Done. Okay, so let's get started. This is what they call a Jupyter notebook, and it's running on Google Colab, and it's made up of a bunch of cells, and they're like text cells or code cells. This top one is a text cell. It's just formatted text just for you to read, and I've just given a few links there that you can go off to look at things. There's the link to this meetup session. I've also got a link to our GitHub site, where you can look at all the previous sessions, and that's a good way of going through, see what other things that we've done in the past, and you'll find the links there as well to pull up the videos and other Colab notebooks, or sometimes we use other GitHub sites and repositories for bigger projects. Okay, so challenge one is how to run Python on your computer. You can use a Google account at Colab Research, and that's probably where you are now, and that's going to be the easiest. And that's right. Alternatively, you can go to python.org and install Python 3.11.5. Actually, in the last couple of days, Python 3.12 has come out, but I haven't even tried it yet, so I wouldn't recommend it yet. Give it a few months to settle down. But 3.11.5 has been around for a year now, and so it's going pretty well. Alternatively, you can install Anaconda. So when I first came to Python, I thought, what's the difference between Python and Anaconda? Basically, Anaconda is just another organization that they bundle Python up along with many third-party libraries. So if you're using those third-party libraries all the time, and you probably find a lot of data scientists do this, they just install Anaconda because it gives them everything they need straight off. I personally prefer to install Python straight from python.org and just install the extra libraries as I need them. It's also a good idea if you're doing some Python programming to have a development environment. So you can use, like a lot of people just develop straight in Google Colab or any other Jupyter notebook. But if you're writing more programs rather than data science, then you'll probably need an IDE such as PyCharm. They've got the free community edition, which is really very, very good. Other people use VS Code, which is also quite good. And if you've got kids who want to learn Python, I've done a course for kids. Check out pythonator.com. It gives they play in a mind test world, which is just like Minecraft, and runs them through how to program in Python. All right, let's get started. Here we are, Google Colab. So you can type into cells, press Shift-Enter to execute a cell, and the cells can be Python code or Markdown text. And if you hover in between two cells, so this is a cell up here, this is another cell down here, if you hover between them, you can insert extra cells, and they can be either code or text. So text doesn't do anything, it just looks pretty, and code is what will actually do stuff. So we've just seen a couple of text cells up ahead. Now here we have our first code cell, and we've put some code in this cell. It's a different color, so it's a gray color, and the code that we put in, we put 3 lines of comments. So these 3 lines, I've started them with the hash sign, which means tells Python they don't do anything. So they're just there so that you, the reader, can read them, and the Python can totally ignore them. Okay, but this line here is actually doing something. It's not technically Python, it's more it's what they call IPython, which is interactive Python, and it brings up help. So if you type a question mark in a code cell, and you don't need any of these other 3 lines there, just the question mark, and you press the play button like that, then IPython, which is what runs these Jupyter notebooks, will bring up some help. Now the very first time we've connected, it takes a bit of time for Google to allocate a little computer for us, and starts running, but now it's running, and it'll be a lot faster next time. IPython's brought up this help, and it just tells you some of the things that you can do. So I'm just telling you that so you know where you can find help. If you're not using IPython, and you're just using a standard Python console, then you can type help with parentheses. In fact, that will even work here as well. So let's try it. We'll just enter a new code cell, and we'll type help, and we'll run that cell, and this will bring up the Python's help utility, and then you can actually, it even gives you a command here, a place where you can type in something else. So say for example modules, that's one example they ask, and it's going through all the modules and bring up these warnings, which are not great in the help package, because you go, what's going on here? So that probably wasn't a great example of a thing to look up, but there we go. How's it going? I'm going to stop it because it's not very interesting. Okay, let's get into doing some Python. Now, first thing we'll look at is some variables. So variables are memory locations where we can store data, and you give the you store the data in a piece of memory, and then you give it a name, and that name is the variable name. So for example, we can have a variable and we'll just call it A, and we'll store the number 3 in it. And the way you do that is you just type A equals 3. Now I can just run that, and it took 0 seconds, so it was very quick to run, and it's just stored the number 3 in a memory location A. Now later on, if we want to find out what has been stored in memory location A, we can look at that using the print function. So we type the word print and then open parentheses, put in the name of our variable A, and then close parentheses. So if I run that now, it'll say 3. 3 is what is in A, and that's good because that's what we put in there. So feel free to follow along, run these cells in your own Jupyter notebook, and even change some of the values if you want to see what happens when you change the values. All right. Now the next, we're using IPython here, which is normal Python plus a few extra things added in to make it more interactive. And so it's interactive means it's got a quick response between the user, that's you, and the Python interpreter. And one of the things that IPython can do is you can just type the variable name A, and it'll tell you what's in it. So once again, I typed A, and it gave back the value 3. All right, IPython, you can even just type an expression. So it's like an arithmetic equation, and you say, I want to take the value in memory location A, and I want to add 4 to it, and I want to see what the answer would be after doing that. So if I do that, I go A plus 4, and IPython comes back with the number 7, which is 3 plus 4. So that's pretty useful. Now you can even do one of these calculations and take the result and store it in another memory location. Say for example, we'll give it the name B. And so here, if we say B equals, and then this expression, it will calculate the value of that expression, which is taking the value out of the memory location A, adding 15 to it, and then dividing that sum by 4 and storing the value in B. But then we want to see what's in B, so I've done a second line here, which has just got the letter B, and that'll say the value of B is 4.5. All right, so we've got a challenge here for you, and I've left a blank space for you to do it. And the challenge is add 123 to 456 and display the result. So you can either stop the video and have a go at this, or if you're pretty quick, you can do it while I'm talking. But if you do stop the video, then maybe put it on a faster playback when you come back so that you can catch up to us. Okay, so here we go. I'm going to have a go at it. I'm going to say I want to take 123. I want to add to that the value 456, and I want to see the result. So I press the play button, and it comes back with 579. So that's the answer. A very simple task. There's a spot there for you to type it. You can try typing something else in there if you want to see how that works, and some of the things that you can do. Okay, now I've provided the solution for you in a slightly different way. I've done it in a way that will work with Python as well as just IPython, and that's by using print functions, as we saw before. So I've got 2 print functions here, and that'll print 2 lines. So the first line prints solution 2 and all of this, and the second line takes our expression, our arithmetic expression, evaluates the result from it, and then passes that to the print function, which then displays it in our cell output. All right, well, there we go. Python's done our first little task for us. Let's have a look at some other things that we can do in Python. Now, I want to show you the language of Python is made up of some keywords, and the thing about keywords is that they are fixed. You cannot change them. They have to. You cannot use any word that's a keyword as a variable name, but there's only a small number of them, and so I thought I'd print out the list of all the Python keywords there are, and to do that I'm going to look at some of the standard libraries that come with Python. One's called keyword, and that just basically gives us a list of all the keywords that are in Python so we can look them up, and the other one is sys, that will tell us our Python system, and I'm just doing that to find out what our version of Python is that we're using, and then I'm going to print them out. So here we go, Python keywords, and because I've imported this library I can now refer to anything in the keyword library by putting the name keyword first and then a dot and then what's in the keyword library, which is the keyword list, and then I've done another string here. This one's a bit more complicated. It's going to calculate how many words are in the list of keywords and tell me what version of Python is, and these are called f strings. I'll get more onto them later. So let's run this, and it says the Python keywords are these, so false, none, true, and as. So let's put the ones starting with a capital first and then the lowercase ones, and as, assert, async, await. Alright, that's all of them. And it said we're currently running Python 3.10.12, which is fantastic. That's actually a quite recent update from Google Colab. I thought they were running 3.9, but now we're running 3.10, and there's only 35 keywords. So let's see how many we can do tonight, and you can say you've learnt a significant fraction of the whole Python language because there's only 35 keywords in Python. Alright, so let's look at some of the easy ones. None. That's one of our keywords there. So we can store none as a value in a variable, n equals none, and it's a value to give to a variable if you don't want it to have a value. So if I say n equals none and then say what's the value of n, it says nothing. There is no value. So in other languages that's similar to null in Java or JavaScript, or nil in or JavaScript. Yeah, JavaScript is nil, I think. Anyway, I can't remember. But it basically means you haven't assigned a value to the object. Alright, let's go back to our keyword list, and you'll see in there's a keyword pass. And once again, this is a keyword. This is a line of Python code that does absolutely nothing. So you might think, why do I need to have it? But there's sometimes you need it when your code is expecting some indented code, but you don't actually want to do anything, so you just put in pass. Okay. Alright, moving on. Variable names. So we've talked about variable names. I started off with A and B, then I showed you the keyword list. So you can't name your variable anything that's in the keyword list, but you can make quite long variable names that are, and if you do that you should separate the different words in the variable name with underscores, and that way it makes your code much easier to understand. And because a long variable name, but you could say something like number of days in year or something like that. Well, I mean 345 is a bit close, but something that it is, so that when you're looking at it later you've got some idea why you've chosen that, what that variable is trying to do. Other languages, they like to use uppercase and for each first letter of the word, and don't use underscores, but I find this way of laying out variable names quite easy to read and looks quite good. Okay, let's move on to data types. So we've had some variables and we've been storing some numbers in them. To find out what the data type is of a variable, we can use the type function. So to call a function, you use the function name, which is type. So it's not a keyword, it's just a function name. So we could actually call a variable type, but that will make your code confusing, because once you've stored data in a variable called type, then you won't be able to call the type function anymore, because every time you talk about type, it'll think it's a variable memory location. Okay, so let's find type of A by putting A inside the parentheses and saying type, and it'll tell us that's an int, which is an integer. So similarly, we could have put a literal number that's not a variable name, literally just type the number in, 456, and the type of that is also an int. So ints are integers or whole numbers. There's another type called a float. So our B value up above was a float. If you remember, B had the value 4.5, so it's not a whole number, while A was 7, so it is a whole number. So the type of B is float. Now, floating point numbers are stored with a mantissa and an exponent, making it possible to store very large or very small numbers in a small amount of memory. So let's have a look at this number here. So if we display that, Python displays it with a mantissa, which is 1.2, 3, 4, 5, 6, 7, 8, 9 up to there, and then an exponent, e plus 19. So that means times 10 to the power 19. Meanwhile, we've got another number here, which so that's a very big number. Here's a very small number, 0.000001, 2, 3, 4, 5. And if I say, how would you display that as a floating point number? And Python, once again, does the same, uses the same notation. In fact, it's even got the same mantissa, but the exponent's different. This time it's so it's by 10 to the minus 14. So it's basically take this decimal point and move it 14 places to the left, and this one is take the decimal point and move it 19 places to the right. For the number before, where we had B equals 4.5, and let's just have a look at that. What's B? And that's called 4.5, and that is a it's worked out that it's easy enough to display that without the mantissa and exponent notation, just straight as a decimal number. All right, now I feel like I am going to get, oh no, I'm not sure why I got this message come up. It's a deprecation warning. Anyway, we'll see if it's not going to cause us any more problems in the past. But you can ignore this one. This is really a deprecation warning is advising people to stop using old functions, and we're not actually using any old functions, but something in Jupyter Notebooks must be for this new version of Python 3.10. But so the warning's not meant for you, it's meant for the Jupyter Notebook writers, and so they'll have to fix that. Alright, so we looked at integers and floating point numbers. Now let's have a look at strings. Now a string is a sequence of characters that make up a sentence or a word. Now you can store a string just by doing it in single quotes, and when you start a string in single quotes, you see a single quote at the beginning and the end, it means that you can actually have double quotes inside the string, and it will be fine, because it will keep going. Python will be looking at this string and going, well, I know I don't end until I get to a single quote, and it doesn't get a single quote till it gets to here. Similarly, if you start the string with double quotes, Python will go, okay, it started with a double quote, it's not going to end till it gets to a double quote, so you can have single quotes inside the string, and it'll just ignore them until it gets to the double quote, then it knows that it's at the end of the string. Now sometimes you want to put in things like you might want to put single and double quotes inside the string, in which case you can either start with triple single quotes or triple double quotes, and then Python knows that the string doesn't end until it gets to the other the same quoting character at the end. And with the triple ones, you can even put line feeds in them. So let's store these values of strings into 4 variables, which we'll call S1, S2, S3, S4, and print them out and see what they look like. So we print out S1, and you see it prints it out without the quotes at each end, because that's just to say this is a string. Similarly with the double quotes, and it's looking all pretty good. This one here is a bit odd. When we wrote it in, we lined the L up underneath the A, but when we printed it out, the L is lined up under the space here, and that's because all these extra spaces in front of the L are now included as part of the string. So if you want to do a string that way, you have to do it like we've done for S4, is put the second line hard up against the left up against the left margin, and there it looks good. And our type of S1 is str, which is Python for a string. Now these characters can be are all Unicode characters in Python 3, which is one of the huge improvements of Python 3 over Python 2, and why you should never even bother. Well, Python 2's been end of life now. It's all finished. It's discontinued. So don't even think about using Python 2 anymore. Okay, now in strings there are some special characters such as the backslash, and the backslash lets you create new characters with a code. So if you type a backslash, then Python will look at the character after the backslash and work out what you're trying to do. So if you take an N, it'll go, oh, you want a new line. If you do a backslash R, it'll say it's a carriage return. Sometimes you may need to put a single quote inside a string that's been quoted with single quotes, in which case you can do backslash single quote, which says don't use it as an end of string, use it as a quote character. And really, same for double quotes. And then the one thing that we really need is how do you then do a backslash? And of course, backslash is your way of doing backslashes. So let's have a look at this. So we've got a 1, and we're printing the 1, then we're printing our special character 1, which was the new line. So it's jumped down to the new line here. Then we've printed the number 2. Where is the number 2? I don't know. But then we're printing the special character 2, which is a carriage return. So what's happened is we've printed the 2, then we've taken the carriage back to the beginning of the line again. So the carriage is the metaphor of the old typewriter, and the carriage was the whole the roll that you had the paper on, and would travel from left to right as you were typing on it. Anyway, that carriage was returned right to the beginning of the line before it's printed a space in the number 3, and that's overprinted over the 2. And then we've done special character 3, which is our single quote, and then the 4, which is double quote, the 5 is the backslash. So I hope this is all making sense to you. Not getting any questions coming up on Slack or chat, YouTube chat, but if anything is not making sense, please ask a question. And remember, this is for absolute beginners, so you're not even expected to have seen Python before. Some people, in fact many people, will have never seen a programming language before, because Python is usually the first programming language which you would try. So yeah, if I've glossed over some parts of it, then please let me know so that I can explain it again. Alright, so that was special characters. And another slightly advanced topic is string prefixes. And I haven't seen this in any other languages, but in Python you have your quotes that delimit your string, but you can also put some more information about the string just before the first quote, and this will tell you something about it. So if I put a U there, then this says this is a Unicode string. Now in Python 3 that's the default, so you don't need to put a U there, but if you're writing code that works with Python 2 and Python 3, then always stick a U in, because the prefix is required in Python 2, otherwise Python 2 assumes that you're using a byte string. Similarly in Python 3, if you do want a byte string, then you can put a B there, which is the default in Python 2, but the prefix is required for Python 3. Raw strings. In a raw string, a backslash is just a backslash, and this is really useful where you're doing things that actually require a lot of backslashes, because then you don't have to be double backslashing every backslash, and you end up spending a lot of time counting backslashes, especially if you're creating regular expressions. So we'll have a look at what this string here, PR, looks like. And then an F string is a format string. Now format strings, this is going to be the most common prefix that you're going to put in front of a string. They are absolutely invaluable for formatting data and displaying it in reports. It's amazing to think that F strings only first existed in Python 3.6 and have been so popular that they've quickly become the only way of formatting strings. And what you do is, as soon as you put an F out the front of a string, then it will look, Python will look inside the string for any examples of curly braces, and whenever it sees curly braces, it will look for the expression inside the curly braces and evaluate that and display that rather than the curly braces that you see there. So if we run this, let's see, run, and look at the output from the fourth string, a format string, to include values and expressions, and you see it's put 3 rather than A, it's put 4.5 rather than B, and then when we've got A plus B inside the curly braces, it's actually evaluated that before it's displayed it, so it's evaluated it to 7.5 and then displayed it. You can even have a look at these other things that we've printed out. We printed out the Unicode string, the byte string, and the byte string, it's even printed with the B out the front and the quotes, just so that it's very clear that it's a byte string. And this is our raw string. You see we've put in a backslash R, a backslash N, backslash T for tab, which would normally be a tab in a normal string, but in this case it's just, we just see it all here. Alright, let's move on to operators. So these are what the symbols that you use inside expressions to when you're doing calculations. So here are some of them. We've got the plus sign for doing addition, the minus sign or the dash does subtraction. We've got the asterisk. So you know, it's pretty common these days. People are used to using asterisk for multiplication, but when computer languages first came out, we'd never use an asterisk for multiplication when we're doing mathematics on pen and paper. But anyway, we've quickly got used to using it now for multiplication. Double slash, that's called integer division. So here we're just dealing with integers. So if we say 27//5 returns 5. So if you calculate 27 divided by 5 in integer calculations, then that's equal to 5 remainder 2. So to find what the quotient is, you use the double slash, backslash, the double forward slash, and to find the remainder you use the modulo operator, which is the percent sign, and that'll give you the 2. So those two can be used together to find the division and the remainder. Double asterisk is used for power in Python. So there's some quick overview of some of the operators, and you'll notice that all the results here are integers, and all the numbers being used as part of the expression were integers. Now, what happens if we change one of the numbers, the a, rather than 27, we put in 27.0. So now it's a floating point number. It's got the same value, but as far as Python's concerned, it's a floating point number. So if we run that, then you'll see that all the results coming out as floating point numbers. So if any one of them is floating point, then the result is a floating point. So 27.0 plus 5 equals 32.0. 27.0 minus 5 is 22.0. So that's floating point, that's floating point. A single slash here will give us floating point division. So that'll give you 5.4. We can still do the whole number division, but it's using double slash. But because one of the values coming in was a floating point number, the result will also be floating point. And similarly for modulo, we get 2.0, and the power is also floating point as well. Alright, time to do a challenge for yourself. Store in the variable C the number 123,456,789 and display double the value of C. Alright, so here goes. I'm going to go C equals, and I'll just start typing 123,456,789. Now I knew what that was going to be, so it was easy for me to just type it in, but it would take me a little bit of time to work out, make sure there were no zeros in there that I had to put in when I'm typing in such a long number. And now I want to see what double that is, so 2 times C, and it will calculate it for me. And I'm getting this warning message, and you probably shouldn't get this warning message yourself. I think it's because I did the help on the modules early on. I triggered this deprecation warning that's going to keep coming back at me. Or maybe it's when it's whenever I do a calculation as the last item in a cell. Alright, how'd you go with that? Let's see if you, let's have a look at the answer here. So when you're typing in integers, Python will actually allow you to type underscores in there to make it easier to separate the thousands. And the reason you can't put commas in there is because a comma means something else in Python. But it'll allow you to do the underscores, and that makes it easier to read these really large numbers. And then it's a lot easier to see that that's 123,456,789. Then we've added C to itself and store the result in D. And then we've used F strings to show us the results. So we could do double C and display the value of D. We can also say we can put 2 times C inside curly braces and show the result there in an F string. And I've also shown you here how to show curly braces in an F string, because obviously if you wanted to show curly braces, it's going to think you're putting in an expression to be evaluated. But if you put double curly braces, then it'll go, oh, actually you do really want to put curly braces, and so double curly braces will display as single curly braces in an F string. And that's pretty useful, primarily for circumstances like this where you're trying to display how an F string is constructed. Now the other thing that F strings can do is they can format numbers. And so if you ever put a colon inside your curly braces, and these are the real curly braces here, you put a colon, everything to the left of the colon is the expression that is evaluated, and everything to the right of the colon is the format that you want it to display it as. So if we use a format of underscore, it'll display it just like we put it in up here, separating each of the thousands by or millions by underscores. Similarly, we could have used a format of commas and it will display it using commas. You can even do fancy things like this format here says, I want you to display the number in a 17 characters wide, and I want it right aligned if it's a number or left aligned if it's a string. I want commas separating thousands and millions, and then I also want to show a decimal point, but after the decimal point I only want to show 3 decimal places, and the number that I will be supplying will be a floating point number. So there's quite a lot you can put in there. You're not going to be able to work out all these f-string formats tonight, but I'll just show you them as I come across them, and you'll remember some and you won't remember others, and that's okay. It's just a practice thing. As you use f-strings more and more, you'll get used to particular formats that you like, and you'll be able to use them over and over again. Alright, challenge 4. Find the remainder after integer dividing an odd number by 2. Okay, so let's say print 3 modulo 2. Let's actually go a big 11. Let's go 11. And the answer was 1. And I'm getting this terrible warning message again. So what I'm going to do to get rid of the warning message, I think, is going to try to get rid of that help function that I caused the problems. So I'm going to delete that cell, and then I'm going to restart the runtime. Okay, so I'll go down to here, run the focus, run before. So I'll try everything up to the focus cell, and then I'll run it. That's good. So that's got rid of those warning messages for me. Okay, print 11 modulo 2, and that returns the number 1. And let's do another one. Let's try an even number. 16 modulo 2. In fact, I'll do it without even the print. And that comes to 0. And that's what we'd expect. Any even number divided by 2 is going to have a remainder of 0. Any odd number modulo 2 is going to have a remainder of 1. So let's have a look at our solution here. And what's that going to, that one in the solution is going to do is print them out. 0 modulo 2 is 0, 1 modulo 2 is 1, 2 modulo 2 is 0, 3 modulo 2 is 1, 4 modulo 2 is 0. So what we've done here, we've actually created a loop. We've got I is a variable, and we've said we can go through this loop 5 times, and every time we go through it, I is going to have a different value, and you can see we're printing I, so we can see what the value of I is, 0, 1, 2, 3, 4. And the way Python works out what's in the loop is by indentation. Now this is quite different to any other programming language, but we've said start the loop here, and I've got a colon at the end here which says I'm about to start a code block. The next line should be indented, which it is, and then everything that's indented after that is included in the loop. There's only one line here, but if you had several lines here, they would all be indented. So like if I said print and a few lines like that, and then so you can see here I've got one print statement that's indented and another print statement that's not indented. And so if I run that, the one that's indented gets run every time through the loop, and the one that's not indented, that only runs after the loop is finished. And so we get our double equals there. Yep. Okay, so it's gone through the loop. Every time it's calculated what I modulo 2 is, and we can see we've got an alternating pattern 0 1 0 1 0 1. That's quite useful in Python. If you sometimes you find you need to have something that alternates on a cycle of 2, so you just use modulo 2 to do that. Okay, so that was loops and modulo. Now we'll move on to this, an advanced section here. You probably never use it unless you're doing like advanced networking stuff, or and that's working on binary numbers with bitwise operators. So we've seen the other operators like modulo and plus and minus. Here are some. We've got the pipe symbol, and that is called bitwise OR. We've got the ampersand, and that's bitwise AND. We've got circumflex, which is bitwise exclusive OR. Double less than sign is shift left, and double greater than sign is shift right. So what I've done, I've created these F strings here to show you, try to show you what these different operators are doing. And I've done them first of all using decimal notation. So 10 or 3 gives you 11. But then I've done the same thing, and in my format strings I've said I want these to be formatted as binary numbers, meaning zeros and ones. So I put a B at the end. I've also put a 4 there to say how wide I want the binary number to be. In fact, down here I've padded the number with zeros to the left. So 4B, I've put the binary numbers, and I've returned the results as binary numbers as well. So it's a bit easier to see what the bitwise operators are doing. So what it does in binary, if I've got 1010, which is binary for 10, and I've got 0011, which is binary for 3, then bitwise OR, it goes through and compares bit to bit and does an OR on each one. So an OR means if it's if either one of them is a 1, then the result is a 1. So we've got 1 and 0 is 1, 0 and 0 is 0, 1 and 1 is 1, 0 and 1 is 1, and then if you convert 1011 back to decimal, you'll get 11. And so similarly I've done that with ampersand, which has gone an AND on each one of those, and that returns the value 2. Circumflex, which is exclusive OR, so that's if only one of them is a 1, then it will be a 1, otherwise it'll be a 0. Shift left, you can see what happens here. If I take 0011 and I shift it left 2 places, I get 1100. So it's moved all the bits to the left. And similarly, if I take 1101 and I shift it right 2 places, I get 0011. That's really just academic interest and a lot of fun for some puzzles, but yeah, you probably never use it. Okay, so we're still talking about operators. We've done operators on numbers. You can also do operators on strings. So we've taken a string here, well, we multiply it by 3, and then we add it to another string, 3 holes in the ground, and try to think what we're going to get for that. Well, 3 holes in the ground. So that's what we got. So it took well, comma, space, and multiplied that by 3, so we got 3 of them, and then added this string to it. So that's how you can construct strings using operators, if that's what you need to do. Adjacent strings don't even need the plus, so I could have put a plus between each one of these, or I can just leave it like that, and they will it'll assume plus if there's no other operator there. Alright, so interesting side effects on using different data types and operators that we've looked at already. Sometimes integers can have more significant digits than floats. And that's if the float reaches a limit. Floats are limited to about 17, but the integers have no limit. So if we run this using floating point numbers, it gives me that many decimal places, and just stops telling me digits after that. I can't find out what they were. But if I did that all in integer arithmetic, I can see what it doesn't show me where the decimal point would be, but I can work that out myself later. But it does show me all the numbers that would be after the decimal point, and I can even see the pattern there. So it's a repeating pattern of 571428, 571428, 571428, 571428. All right, so that's integers comparing to floating point. And another one is floating points are actually stored as binary numbers, but you can't store 1.1 exactly as a binary number. So there's a little bit of an error there, and that's called floating point error. So for example, if you ask Python to do the calculation, 1.1 plus 2.2 seems like an easy enough calculation. Python will come back with 3.30000003. And that's because they don't store decimal numbers exactly. So if you're doing science, that's fine. It's not going to cause you a problem. If you're doing accounting, that can be a problem because they like everything to be exact. So if you are wanting to write an accounting package in Python, then just do it all in cents and integers. Right? Don't use floating point numbers. Or use a different class other than integers, such as the decimal class. Okay, challenge 5. Find the integer quotient and remainder when dividing 6666666 by 235. So we just go. Now I want two numbers on the same line here. So I can actually, in IPython, I can just put a comma between them. And it'll calculate both of those and give me the two results. So the answer is 2,836, remainder 206. Let's just put a comma between them. Okay, calculate 2 to the power 10. Remember the power is double asterisk, 1024. Find the decimal quotient of 666 divided by 235. To 836.87659, which is what you'd expect, something like that when we had it was 2836 remainder 206. Store in a variable the name of your favorite programming language as a string. So let's see, we go lang equals Python. Construct a new string that starts with programming in. So let's call it sentence equals programming in, and finishes with is fun, and includes the value of the variable in the middle. Okay. Plus lang plus is fun. And I guess we better display that result. Alright, now if I put a little error in there, see if you can spot it. But we'll see it when the result comes out. Programming in Python is fun. So I didn't leave a space in here, so I have to leave a space. Now I did leave a space there, so that worked out all right. But now I'll put the space in there and try it again. See if I get it right this time. Programming in Python is fun. Yep. So here are the solutions, and I've done it all using F strings. And let's see, is there anything interesting there? So the way in the solution we constructed the string was to use an F string rather than using string arithmetic. So we used the curly braces to embed C1 into the middle of this string to make C2. Okay, the data type bool. So bool means Boolean, after a scientist, Boole, who was interested in logic, and it stores the values true or false. And so they're the results of different operators. So if we want to see if something equals something else, we would use double equals. Anyway, let's have a look at type of true and false. Yep, they're both bools. Let's see how we could see if something equals something else. So here it is written 3 equals 5 minus 2, and that comes back with true. So if you're using a single equals, that means assignment. So that's when you're assigning a variable with a value. But if you use double equals, then that means an equality tester. So that's checking if two things are equal to each other. And we can use all these other operators which all return Boolean. So we can do exclamation mark equals is equivalent to does not equal. So it's like an equal sign with a slash through it. That's your less than, your greater than, less than or equals, greater than or equals. In means if you want to check if something's inside a list. Or is if you've got two Booleans and you want to see if either of them are true, then you look for or. And if you've got two Booleans and you want to make sure that they're both true, then you use and. Not will reverse a Boolean, so true, not true is the same as false, and not false is the same as true. Is is a, that's an identity operator. So I don't know that we're going to get into is tonight. So normally you'd want to use equals if you're testing for equality. Don't use is. But let's run these and see how we go. So 45 greater than 23, that should be true. Yes, it is. Minus 10 is less than minus 20. Well, I think that's false. Python thinks it's false as well. C1 equals Python, and that is true. Yeah, so we've stored the values Python in C1, and we can compare C1 to the string Python, and that's come out as true. All right. Predict the outcome of the following Boolean expressions. Well, may as well just run them and see what happens. So C1 equals Python, and remember C1 has got a capital P in it, and we're comparing it to Python with a lowercase p. So what do you think is going to happen there? And the result is false, because C1 is Python with a capital P. So the equals when you're comparing strings is case sensitive. So let's have a look. C1 does not equal Python is true. 253 is greater than or equal to 1518 divided by 6. Let's have a look, and that is true. I couldn't really tell you off the top of my head. See if it's less than or equal. Returns true. Oh, okay, so it's both greater than or equal and it's less than or equal. So I think we can assume that it's equal. And here it's calculated the result in the parentheses, in those curly braces, and we said 253 less than or equal to 253, and that returns true. And that's interesting because here we're comparing an integer with a floating point number, but it can still do an equals on those and say that they're equal. So there's a if you want to look at some mathematical constants like pi or e, then you can import them from the math library. So let's have a look at e, which is 2.718, which is your natural logarithm exponent, or pi, which is the radius, the ratio of the diameter to the circumference of a circle. Is 3.14. Obviously they're rational numbers, but floating point numbers only store about 17 decimal places, so they're not exactly correct, but they're good enough for most uses. In maths, there's another Greek symbol tau, which is, let's get rid of this, which is equal to 2 times pi. So if we said, is tau greater than 2 times pi, we'll get false. And you see what we can do here, we can actually put several numbers with, so we can have several operators along the sequence of numbers, and it will check that they're all true before it returns what the overall result is. So that's something I haven't seen in other languages either. Okay. Now we can use less than signs for comparing strings and characters. So if we compare A to C, then that'll give us true because A comes before C in the alphabet. However, if we compare lowercase a to uppercase C, we'll see that that's false, and that's because all the uppercase characters appear before the lowercase in Unicode. So the way it's calculating this is looking at the code value of these characters and where they appear, and the all the uppercase ones were done first and then the lowercase ones second. So it seems a bit strange, but uppercase is always comes before lowercase in when you're comparing using less than and greater than. Once again, upper is less than lower, even though you'd think in alphabetical order that's the other way around. If you've got words that start with the same few characters, it keeps going till it finds a character that's different, and here we're comparing T to R, and then that will return false because T is actually after R. We can use the in operator, we talked about that before, to see if this substring is part of the main string. And so at in catch returns true. AC, both those letters are in catch, but they're not adjacent, so that substring is not in catch, so that returns false. And TA, they're adjacent, but they're in the wrong order, so once again that returns false. We'll have a look at ors and ands. So you get a true or false, that returns true. True and false returns false because it needs both of them to be true. And here's an interesting one that I can never remember, so I will always use parentheses so that I know exactly which I want to calculate first. But if you're calculating both an or and an and in an expression, then it does the and first, and then it will work out, then it will use the or. So if I say false and false, that's equal to false, and so I've got the result of that, which is false, and I do false or true, and the result of that is true. And so this is returning true because and has precedence over or. Similarly, there's another example of the same thing. False and false or true returns true. Okay, and here's, I do show you is, it means that they're both referring to the same bit of memory, and by saying C2 equals C1, that is a way of saying I want C2 to point to the same piece of memory that C1's pointing to. Then I can actually check for it using is, even though it will show false. So let's have a look at what's in C1. C1 is Python, so if I said C1 is Python, we know we checked it before with equals and it came up true, but when I check it with is, and it's saying, yeah, did you mean, alright, so let's go C2 equals, and okay, so I was trying to demonstrate that C2 is not necessarily the same memory location as C1, because we've stored, even though we've stored the same string in the two places. But Python was a little bit cleverer than me, and it's when it saw that I said C2 equals Python, it goes, I'm going to save a bit of memory. Strings can't be changed in place, so therefore I can just point C2 straight to C1, and it'll have the same effect as me saying C2 equals Python, and so it's come up as true. So so much for that demonstration. But what that's meaning is that the ID of C1 and C2 are equal, and I can demonstrate that by using the ID function. And you can see it's stored them both in the same memory ID location. Alright, how are we going? I'm running a bit over time, but anyway, it's been fun. Define a list with square brackets. Okay, so more complicated data types. We'll look at lists, so you can define them with square brackets. And inside the square brackets, you can put all sorts of different data types, yeah, even other lists. So I'll call my list LST. I don't want to use the word list because that's actually used for creating new lists, or converting things to a list. But what I can do here is I just use lst, and I can store my list into a variable and I can print it. And then I can call up any particular item out of my list by using indexes. So if I do square brackets and then the index value, so 0 will be this first one, it will return 6, and list 1 will return 5, and list 6 will return 0, which is this item here. Now a clever thing you can do in Python lists is you can count the index back from the end. So list minus 1 comes back 1 from the end, and that gives us 0 as well. So I can refer to that same one as either list 6 or list minus 1. And this actually saves a lot of time when you're wanting something like the second last. You can just go list minus 2 and tell me the second last item in the list is 1. We can use the length function to find the length of a list. And there's 7 items in my list. I can do slicing. I'm just going to race through this because you're probably not going to remember it all, but it's good to that you've seen things that you can do, and if there's any particular one, you can look at it in more detail later. So I can slice up my list. I can say I want to go from 2 to 5. So that's my index, and if I look at that, it gives me 4, 3, 2. And the way so what it's done is it started at number 2, which is 4. It's given me up to, but not including what index 5 is pointing to, which is 1. So the reasons Python does that, I can tell how many are going to be in the list by just going 5 minus 2. I'm going to get 3 elements come back. Also, the way I think of the indexes is it's counting the positions between the elements. So 0, so here are my elements here, and there I've drawn below where the indexes are. So 0 gives me 6, 1 gives me 5, 2 gives me 4, 3 gives me 3, 4, 2, and so on. But if I want to do a slice from 2 to 5, I just get the values that are between 2 and 5, which are those ones, 4, 3 and 2. And I don't get the one that actually 5 is pointing to. I could do this with the negative indexes as well. So that's where the negative ones are pointing. If you want to slash from the beginning, you don't need to include 0. You can just leave it blank and it will start from the beginning, and you say go up to 4. Slicing from, if you want to go all the way to the end, and that's probably more useful because you don't actually know how many are in the list, then you can say start at 3 and give me all the ones up to the end. Here's something I've never actually did use it the other day. This for once. You want to slice, but you don't want to go every single item. You want to go up in 2s. Then you do 2 colons, and you see it's taken every second item from the list, starting from number 1, which is 5, 3, 1, and it's left out the even numbers. And you can even put a negative counter there, so you have to slice if you want to go backwards. But when you're doing that, you want to start at the end and go to the beginning. So otherwise you'll get nothing returned. And here we go. We've reversed the order of the list. 0, 1, 2, 3, 4. We've done all these things on the list, but still the list is still the same list. But we can assign an item into a particular part of the list. So at the moment, the item at index 2 is the digit, the floating point number 4. But I can assign that to the string FOUR, and you can see that the new list has been changed in place, and it's now got a FOUR there rather than 4.0. I could change the last item in the list using a negative index, and now I've changed the 0 to be blast off. You can even delete an element from the list using the delete keyword. So 3 has gone. That's because it was index 3, not because it was the string 3. So that was a bad example to choose. But anyway, it's now gone because that was what was at that index. Okay, strings can do many of the functions of lists. For example, slicing. We can take DEFG is just from 3 to 7, and there's 4 characters there. And that's all we'll do on strings. Okay. I mentioned before the decimal standard library if you're wanting to do an accounting application. So I'll show you how to use it. The standard library is called decimal, and you see it's there with a lowercase d. So we can import that. And once we import it, we can then create objects of the type decimal from that decimal library. And this is a class, so it starts with an uppercase number. And then we have to pass in the value that we want. But we can't use it as a floating point number, because remember, floating points can't be stored in binary exactly. So we store it as a string and pass it to decimal that way, and then the decimal library can work out how to use it from the string without it having to go through that step of being a floating point number with the inherent floating point errors. So I can create a decimal for 1.1 and a decimal for 2.2, and I can add them together, and it tells me the result is decimal 3.3, and is exactly 3.3. So that's what we're wanting to see, not 3.300000000, etc. 3.3 at the end. All right, but it's still it's a little bit verbose, having to type decimal.decimal on every time you wanted a decimal number. So what you can say is, well, in this decimal library, there's only one thing I want to import, which is this decimal class. So I can say from that decimal library, just import the class, and I'll just use that. And we can see here that's made it a lot more succinct for doing the calculation, creating these decimal objects. Still not great, but it's better than it was. And then it displays straight. It displays the same way. It doesn't know how we've imported it. So it's always going to display the result the same way. But what I've seen some people do, especially for decimal, because you're having to do all these decimals everywhere, is you can create an alias. So I want to import the decimal class, but I don't want to type the word decimal every time. So I'll use this as function to give me an alias to decimal. And now I can just create decimals using my D class creator as an alias. So that's using an alias on just one thing out of a library. Many people in data science, well, in Python you can alias the whole library, and in data science people will normally alias these two libraries as PD and NP. And so I'll just run that just to show that that's a valid piece of code. All right, we've covered quite a lot here. These are all the keywords I've created. So I've just created a string here, and I say split the string on this symbol, and I'll create a list so that I can count it. And the number of keywords that we've covered tonight was 14, and I think if you remember there were only 35 keywords totally in Python. So in the hour and a quarter we've been going, you've learnt well over a third of Python, the Python language. So by that, if that's true, then 2 more hours and you should have all of Python totally covered. That's my joke. All right, so there were 35 keywords in Python 3.10.12. Hope you enjoyed it. I hope you learned something. Sonic Hedgehog has said they're doing okay, which is why they haven't asked me any questions. I'll just check in Slack to see if there's any questions here. No questions. What is going on here? I'm trying to get the title bar in Slack and it's won't let me grab it. Okay, I've got one question here. This looks like it's from an absolute beginner. This guy Peter Fitzsimon, what's Python? Yes. Well, I think, Peter, you'll have to come back again and again and again, and eventually you'll learn. All right, here we go. Thank you. That's good. I'll run through the challenge. That's a great idea, and you're doing it in your own time, and you really don't learn until you do stuff. And I think Google Colab is just a fantastic way of giving you immediate responses to stuff that you type. So yes, go through that and go through those challenges again, and that'll be the way you learn, and try to think about what the results you expect to get before you run any of the cells. Okay, so next week Arun will be doing machine learning, and he'll be looking at AWS something. Let's have a look at what's going on next week. AWS Bedrock and generative AI. He's got the date of October the 4th there, but that's wrong. So hopefully he'll get that fixed. And our next in-person session will be on November the 1st. It'll be how to write GUI apps. It'll be try to be designed for absolute beginners because it is the first week of the month. But it can be quite involved writing GUI apps. So a GUI app is an app with a graphical user interface. So it'll show you how to use buttons and forms and how to start up an application and things like that. All right. See you all later. Oh, here we go. Is Anaconda an IDE? No, Anaconda is not an IDE. Anaconda is a collection of libraries, but it does ship with an IDE. There's one in it called Spider, but it's a pretty simple IDE, and the fact that PyCharm Community Edition is now free, and the fact that VS Code or Visual Studio Code is also free, and they're both very good IDEs, I don't think there's any need for you to spend any time with Spider in Anaconda. So feel free to install Anaconda, but also if you're wanting to do Python coding, then and you want an IDE, then don't use Spider, use something like VS Code or PyCharm.